Hi, welcome to very first Java tutorial. Before we getting started with Java tutorial, first we can discuss about what is the necessary of having programming languages and why we have chosen particularly Java in our choice apart from other programming languages. This is the typical computer we have in front of us. This will understand only bytecode. The bytecode will contains only ones and zeros. So generating bytecodes and giving it to the computer, it will be very difficult for us. To solve this problem, there are different programming languages came into the picture. We have a set of programming languages. We have like COBOL, Java, JavaScript, Python, C++, PHP, Shift, the Objective C. There are different programming languages we have, and .NET even. Uh, these programming languages actually what does is it will actually take normal English from us, and it will actually convert that English to bytecode. So it's a English, it's not a normal English. It's kind of structured syntaxes we'll be having. We'll go through that one by one. So these structured programming that will called as programming. So this structured programming will actually convert it to bytecode. The bytecode will pass it to the OS, which is our operating system. So the operating system performs our uh, op- instructions, whatever we mention in the program, and it will execute those bytecode and it will return the response in our readable format. So Java, why I have chosen is particularly it is actually a platform independent programming language. So it can we can write it in any platform and we can execute in any platform. So it's like suppose if I write a program in Windows machine, so I can able to copy the class files and I can use the same class files and then I can execute those class files in Linux box as well. Vice versa, you can able to write a program in Linux and you can execute in Windows as well. So the that is the only the reason I have chosen Java as my programming language. That it is very much lightweighted as well. So first we are going to discuss about core Java today. So the core Java, the topics will cover introduction of Java, Java installation and setup, features of Java, first Java program, which is Hello World Obvious, Java Development Kit, difference between JDK, JRE, and JVM. I'll detail everything later. JVM architecture, which is Java Virtual Machine. First, we can start with Java introduction. So what is Java? Java is a programming language and a platform. So, what is programming language and what is the platform? What is the difference between both of them? So, programming language is what we discussed earlier, like converting uh, structured English to bytecode and getting response from OS and returning to readable format of English. So these kind of things will happen in programming language like C, C++, and Java as well. And the platform is particularly it's more about providing a runtime environment for the program whatever we are writing. So usually C or C++ directly run on the OS. If it is a Linux OS or Windows OS, it will actually directly hit into the OS DLL files if it is a Windows, and it will actually run out of OS files. And if something broken, so the OS will definitely impact. To avoid that, what Java is using its own running platform. It is Java Virtual Machine, which will be placed on top of the OS, and if something happens, so only it will impact to the virtual machine, not to the OS actually. That is the reason Java is called as secure programming language. Along with security, it is having object-oriented features like inheritance, polymorphism, um, uh, uh, object-oriented programming. Everything it will include, and we can discuss object-oriented concepts later. And it is a robust. What is a robust? Robust means it is about memory management. In C, C++ programming languages, we need to allocate memory and we need to deallocate memory. So if you consider here in Java programming language, we don't need to particularly bother about allocating memory or deallocating memory for any data type. So the memory management system in Java is very much powerful. It will actually take care of allocation and deallocation of memory of each data types of the variables. So we can go to the next, and it is about Java types of Java applications. What are the different types of Java applications we can able to develop? So each programming language will have some capability of developing programming languages. Suppose if you take C or C++, we can develop only standalone applications, and we cannot. It is not possible to develop web-based applications. But Java is having scope of developing standalone applications as well as web applications, enterprise applications, and mobile applications as well. So the web application is what we are in nowadays. We're looking at any website like so Facebook or IRCTC or any website you're browsing. Those are all called as web applications. So enterprise applications is about the banking websites and all will comes under this category. Mobile applications, developing mobile applications, they're using Java also possible. So for each type of application we are developing, we have different platforms available in Java. Suppose if you want to develop standalone application, then you can use it. Java SE will be fine. Standard edition will be fine. You don't need to use ME and all. And for developing web applications or enterprise applications, we can use Java EE Enterprise Edition. And particularly for mobile applications, uh, we can use Java ME, which is micro edition of Java platform. So these are all the list of platforms we have, and next we can discuss about how we can have the local setup and how to install Java in our local machine. Java installation. You can simply type Java download. Their list of URLs will be listed. There will be different sources, but it's recommended to choose Oracle website for downloading Java software. So if you see the list, there are different versions available. Java 12.0 and Java 11.0, Java 8.8U2221. So different versions are there. This we can call it as Java 8, and this we can call it as Java 11, and this one we can call it as Java 12, which is latest. I suggest you to download the latest version of Java, whichever is available, and so that we can try all the features what are available in the latest APIs. So you just need to click on the download link, and so it actually lists out what are the available options available. We have to accept the agreement. Then if it is a Windows, then we have to choose these links to download, and if it is a different OS, Mac or Linux, so we have to use these links. So as it is a my Windows machine, so I'll be downloading Windows version of Java. I think I have already downloaded, and so it is already available in my downloads folder. So you just need to click on double link, and then the next and finish options will be followed, and everybody knows how to install this hardware in Windows. So once the installation is done, then the checkpoint will be you have to navigate to computer, see program files. If it is program files, or might be program files x86, depends on your OS. While installing Java, it will actually prompt for which folder you want to install. That option also will be there, and if you want to change different folder also, you can able to choose that. So by default, it will comes here. So here it is Java, and the version I have installed is latest JDK 12.0. And these are all the different folders we have. We can go through them later. So the installation is done, and then we have to check whether installation is happened properly or not through different application, not browsing the folder structure. So for that I'm doing command prompt, just prompting my command. Here I'll be typing java-version, which actually lists what is the correct install version is available in my machine. The expected result will be obvious. It's a Java 12.0. It is what I'm expecting. Oh, but crazily it is showing Java is not recognized. This is the standard error. Everybody will get it. So how to resolve this? The way to do this is, it is clearly telling like Java, it is not able to identify what is that command it is. So for that we need to set path and class path. The way to do this is, go to the bin folder, copy the path from browser, and here you can set path and the class path. So for Windows, we'll be using set path equal to the bin folder location, and class path also same location. For Linux machines or Mac machines, we have to use export command. Export uh, path equal to same value where the Java is installed, and export class path equal to. As I'm a Windows machine, so I'll be using set commands. So we can check the Java version now. What will result we'll see. Now it is returning Java version properly. And the other commands we have to check is Java C is working or not. It's working. Java is working or not. So Java and Java C, these two are the important commands if we have to check it, and if these two are working, so our setup is done properly. So where this Java and Java C are available, why we set this path? Because it is, these files are already available in this path. Suppose if you see this bin Java exe we have, this is what we are calling as Java, and a Java C will be there. Java C.exe. So these two we are setting as path. So that is how we can set it as path, and we can access the Java version and other commands. We'll come back to the slides. So how to set path in Java, which is what we have already done, but there is additional step we have to do. Suppose if I close this window, if I reopen it, it's a fresh window. I'm typing Java-version now. The expected is 12.0 because we already set the path, but still it is showing Java is not recognized. The reason is once you close this session, there itself our setup will be gone. So it's difficult to set every time and execute a Java program. So somehow we need to make it permanent, or permanent setup kind of things for making this Java version or Java to be run in any path, not only in this path, any path it has to run. Suppose once I open command prompt anytime, so if I type Java-version, I'm expecting it has to return right version, and every time the setup has to be saved. The way to do this is, go to the advanced system settings, we can close this window for now, we can test it later once the survey is done. Go to advanced settings, or if you have later older version of Windows, maybe you can use this option. Right click on my computer and properties, if you click on it will open the same prompt, and here we will be having there will be different tabs: computer name, hardware, and advanced. We have to go to the advanced tab. There we have to go for environment variables. Here the environment variables are available in two ways. One is user specific and global specific. User specific means for the logged in user only you want to set the attributes, or for all the users you want to set the attributes. It's up to your choice. For now, I'll be adding for my user alone. I won't be allowing to use Java commands for other users. So for that reason, I'm using these. And if you want to use, everyone has to use, then you can set it here. There's no difference in adding option, but functionality wise, it will differ. Suppose some other user logged in, so I cannot able to use it if I add it here. The way to do this is copy this path again, create a new. There you can set it as path, copy the value, save it, gain one more variable, class path, paste the value, and save it. Okay, okay. Now we can test our changes, whether it will actually reflecting or not. Doing the same thing, I'm opening new command prompt, fresh one, just checking. Yeah, it works. We'll check other commands. Java C works, Java works, everything perfect. We can go to the next slide. So features of Java. What are the different features we have it in Java, and we can see it now. Features of Java are simple, object oriented, portable. So what is simple? Writing programming language is very much simple in Java. So object oriented programming. Object oriented programming means, as I discussed, like it will be having all the object oriented features like inheritance, encapsulation, polymorphism. All the features will be having here, and it is a portable. We can install it in any OS and we can run it in anywhere. Platform independent. Platform independent, it means that if you're writing a Java program in one OS, suppose if you're writing Java programming in Windows, you can copy those files and you can paste it in Linux machine or Mac machine. There you can run it. So the output will be same. There's no difference. The vice versa. You can able to run create a program in Linux box, and those Java files you can move it to Windows machine. There also you can execute. That's what platform independent. Once you execute, you don't need to even copy the source file actually. You can only copy the .class file. I can explain you once we started programming what is class file and what is Java source file. And it is a secured. As we discussed, Java runs on Java virtual machine. So it is a secured. It will not directly impact the OS. It is a robust. Robust means its memory management will be very much powerful. Allocation and deallocation will happen taken care of Java itself. We don't need to particularly care about it. Architectural neutral. What is architectural neutral? Architectural neutral means suppose if you're writing any programming language, any program in Java, so you can directly you can have the source code and you can copy to the different OSs, and there is no impact affected. And the data types, suppose if you declare, suppose int and float, if you are declaring, if you look at the C or C++ programming language, there you can find the difference, like for each data type, for each voice, it will works differently. Suppose int is taking 2 bytes in Windows, and it might take more than 2 bytes in Linux box, but that's not the case in Java. So for each operating system, the memory allocation will happen equally. There's no differences you can find it with Java. The performance will be high compared to these structured programming like Java, C or C++. It will be lesser actually. C or C++ will perform better because it directly runs on OS. But how I'm telling it's a high performance means it's compared to other programming languages like .NET or PHP. These kind of programming languages, it will be better performance it will give. And we can able to develop multi-threaded applications in this, and distributed applications we can able to develop, and dynamic. web pages we can able to develop. A lot of things is possible with Java. We can go through each topic when we multi-threading and all events started. Then you can understand how we are actually writing thread programming in Java. We can discuss these details in later. Writing a first program. For writing a first program, I can go to my download folder. Writing a first program, it's about creating a new file. The name I can give it as sample. As we are writing Java program, the extension will be Java. Saving it. So I'm editing this file. Currently there is no content we have. I'm writing simple Java program which will actually print hello world. Public class sample. I'm done with it. So this is a simple Java program I have written. So the whole intention of this program is to print hello world message to me. That's it. I've saved it, and I need to execute this program. To that, I'm opening command prompt. I'll minimize this window so that you can able to see all the content over here. So we need to go to the download folder where our source file is available. So to run the Java program, first we have to compile the program. For compilation, we have to use command called javac. Javac means Java compiler. So I'm initiating Java compiler to compile my sample.java file. So once I executed this, the expected output will be it will actually generate a .loss file which is in the same folder, which names as the same. It's like sample.class. See, it's got generated. So to run the program, we need to use Java command and class name. Whatever we declared here, that name we have to mention here. Once I run it, yes, I got the output. Hello world. So these hello world program, we are done with it. And these are if you write n number of Java classes, n number of data files will be generated. And as we discussed earlier, the platform independent programming language, so we can copy this .loss file to different operating system, either Linux or Mac. So you can able to run the Java command over there directly with the .loss file, and you can get the same output over there. So these are Java code sample code we wrote just now and we tested it. And Java code actually comes to the compiler, which is Javac, and it will actually generate a bytecode, and which is actually giving to the JVM. The JVM details we can discuss in later. So the coming to the details of the Java program. So class sample. So once you're declaring any class, we need to mention class as a keyword and name of the class, and public. Public means uh, anywhere the class file the class and this method will be accessible. Static. So we don't need to declare an instance for this, and we can directly call this method anywhere. So void means it is not returning anything. and main is the name of the method, and these are all the parameters of the method, string args. So these the system is a class, it's a predefined class which is there in the uh, predefined libraries. Suppose if you see, there are different libraries available in our JDK. So system class we haven't defined, it comes from the default library. So these are all the different libraries available in the jar. Suppose J RTF fs.jar, and these different jars will be there. These actually contains these system class and their methods, and we'll be passing our input. It is actually printing the response for us. And there are different ways we can write it. It's not only this format we can write the public static void main. There are different ways we can run it. Like these not the standard way of these not only the standard way. These not the standard way. It's wrong. These not only the standard way. We can write it in different ways. We can see it later. So these are the ways we can write it. This is the standard syntax we wrote. And the public static void main. The parentheses are changing. It belongs to args now, not to the string. So we change the position of the parentheses, and this dotted parameters also works same. And here we change the order of the names. So suppose we have public static first, here static we move to first and public we move to second. Order is not a matter, but this has to be prior to the main method. The return type, whatever the return type we will be having, that has to be prior to the main method. And we can even add final keyword for that, and the final keyword what it is, and we can discuss in a later point of tutorials. So Java development kit, which is JDK we are actually talking about. JDK actually comes in, as we discussed, in different versions will be coming. Like one is this Java Standard Edition, Java Enterprise Edition, and the Micro Edition, which is for mobility. So apart from JDK, what is actually contains the JDK, and what is there inside JDK? These things we can see it now. Differences between JDK, JRE, and JVM will also means that how JVM architecture and the JRE architecture and how JDK, these three how actually combine together, how they are actually stay. We can see it now. So these are typical architecture for JDK. Usually JDK will contain JRE, and JRE will contain JVM. So JVM will not physically exist, and JRE will exist physically, which we see the library files and all which comes under JRE, and the JDK also physically exists. Where apart from JRE, it is having additional tools like Java C and Java, which we run those commands, and we have seen the files also in uh, Java bin folder. So among all JRE, JVM, and JDK, JVM is only the virtually exists. It's not the physically exists. Like you cannot able to directly see that, but JRE and JDK you can able to see the content. Like physical files, you can able to see that. So it's a very important topic. What is JVM and how this architecture works? Uh, Java Virtual Machine is the heart of the Java, I can say. It will contains how to load the class. Suppose once you generated the dart class file, right? Once you're running the Java sample, from there JVM actually initiates, and it will actually to generate this output. What it will do? That's what the JVM we're discussing about now. So JVM, what it actually do is it will actually loads the dot class file. This is loads code, and it verifies that bytecode whether it is having proper syntaxes and proper uh, programming syntaxes it is following or not, predefined structures it is following or not. Once all the validations are done, then it will actually move to the next phase, which is execution phase. Once the execution is done, there it will actually execution phase. It will actually uh, runs the code, and then it will provide the runtime environment. So apart from that, it will actually once class is loaded, there it will actually look into each and every line of the statement, and it will actually allocate some memory to each type. Suppose if int variable if you declare, so it will actually suppose if you are declaring int, what are the memory it has to allocate, that allocation will happen instantly in the JVM. We can see the architecture, we can get the details more. So these are JVM typical architecture. Class loader will actually load the class. In class loader, we have different class loaders will be there, and a bootstrap class loader, and different class loaders are there. Bootstrap class loader actually does this. It will actually loads the classes into the uh, class loader, and then it will actually verifies the code, and it will do the basic memory allocation and all. There are different memory allocations are available. One is class area, heap, stack, PC register, and native method stack. Native method stack, which is actually used for if you are calling any native methods inside Java package. Suppose as we called in system dot out. Suppose if you are calling these are actually native method call, because this class we haven't defined, and this comes under Java native library. So this is the native method call actually. So this comes to this place. So what are the method calls it is having? It actually comes here. So PC register actually does is what is the current line of execution it is holding. So suppose if I have this program, it will execute line by line, one by line it will execute. So what is the current line of execution it is having? That line of details it will PC register will hold. The stack will have, suppose if you're calling any method, uh, the methods and all we can discuss it in further tutorials. There we can understand. Suppose if you're calling any method, there uh, uh, the calls will be registered in the stack memory. And heap is the actual thing like where original objects will be stored. Suppose if you are declaring any int variable over here, int x equal to 10. So these actual of this value will be stored in the heap memory. Or if you are declaring object for this class, that is also stored in heap memory. The class area will store only the static uh, data. Static data means it will actually only one memory allocation will happen per class. Suppose maybe these are all the heavy topics. Maybe you can get these details later, but for now I'm explaining. Class area which actually holds only static data. Suppose if you're declaring any variable as static, these are non-static. If you're declaring static int y equal to 20, this is a static variable. This y allocation will happen in the class area, and x allocation will happen in heap area. Once the memory allocation is happening, or once the bytecode verification is done, everything is done on native. mm, uh, if something to be integrated with, suppose if you are writing some code, and some native method calls also if you are using, like system.out.println, we have used all the code combined together, and it will comes to the execution engine, and execution engine will execute the code, and it will return the output. So these about overall architecture about JVM, and we can have one more separate video for this JVM alone. There we can see what kind of loaders will be having, and how memory allocation will happen, and how uh, the memory will be swept out, and how new memory allocation will be created, and these and all we can discuss in separate video. There it will take a separate video for that, and there we can discuss it. And now we can go to the next topic, which is Eclipse IDE. So what is the reason of having any IDE like Eclipse? Or we have different IDEs are there. So IDE is what used for development environment, and we have different IDEs are there, which is one is Eclipse, NetBeans, um, uh, JDev. Different IDEs are there. Uh, we have chosen Eclipse is particular is about it's a open source. It's a lightweight. We can execute easily. The reason we'll be having IDE is like suppose if you're writing Java files like this, if this is a simple program you can able to write and execute. Suppose if you're writing a lot of programs, so every time you have to run these commands, so Java C and Java, every time you have to run it. So these things will automate in the IDE. And suppose if you're writing any predefined classes, suppose system.out.println if you're writing, so auto-populated values will comes in the IDE, so we don't need to remember all these things, and we have to remember mandatory things, but syntactically it will be development time, it will be faster if you're using any IDE. Suppose if you write system dot means it will automatically populate out error, different methods what are available, it will actually populate, and it will be easy to maintain, until packaging on, so we can able to view, and everything will be comfortable to code actually. So there are different IDEs. There are NetBeans a lot of people are using, and Eclipse I prefer to use it. A lot of tools on top of Eclipse came, and this is very much popular in IT. So you can go to, so the download packages different. If these are the latest package they have, and if you want to see different packages available, so you can able to go through that. Here more downloads, you can able to find all the versions of Eclipse available. So the older versions will, if you want to see older version, you can go through it, and it's good to download any stable version like till Python. It will be Python. It will be recommended to download. It's up to your choice, boys. And I there will be like if you download, if you have Java version, depends on Java version also it has to choose, like suppose if you're having Java 8 or up means 8, uh, 10 or 11, maybe you can go through Oxygen port on. For the lower version I don't think these will work. That is the reason I'm recommending you to download the latest version of Java. That once you download the latest version of Java, then you can install any version of the uh, Eclipse that works fine. The same way for NetBeans, it's up to your choice, which are the ID you're comfortable with. Even if it is a new ID like IntelliJ ID, also it is good actually. Uh, Maybe we can start developing our programming languages, our programs using Eclipse IDE in a later point of tutorials. I'll also download, I'll install it once, then I can. The installation is simple. About suppose if I need port on, can go through that, and I recommend you to download Java E version of IDE. The reason is now we are starting with the core Java. For that, Java's IDE for Java developer will be fine. But if you download Java EE, you can able to develop standalone applications along with web applications. So that is the reason I recommend you to download Java EE version of Eclipse. So it depends on your OS, 32-bit or 64-bit. You can choose the download link. Then you just need to simply click on download. The download will happen. So the advantage with Eclipse IDE is compared to NetBeans. So NetBeans you have to install the software in the OS. For Eclipse, it's not the case. You can have, it's a runnable file. You just need to download it, and you need to double click on it, and it will be a runnable file. You don't need to particularly install the exe, and you don't need to run it. It's kind of executable file. You can able to directly click on, double click on it, and it will open. It will execute. And you can able to write the programs. Maybe a later point of programming tutorials, I'll be using Eclipse IDE for you. And that's it for this tutorial. Thank you.